Assalamualaikum and hi everyone. This is subtopic 1.3, parallel and perpendicular lines. Before we begin, make sure you complete the induction activity attached to this slide. This topic is a continuation of subtopic 1.2, equation of straight lines, and we'll be applying a lot of the knowledge we learned there. So let's go. Let's start our lesson with the learning outcome for parallel lines. By the end of this lesson, you should be able to 1. Determine if two lines are parallel. 2. Calculate the gradient of parallel lines. 3. Find the unknown value in the equation of parallel lines. 4. Determine the equation of parallel lines. And 5. Answer at least 8 out of 10 tutorial questions correctly within 30 minutes. Now, let's explore how this subtopic is divided. The parallel lines subtopic is split into 3 main parts. First, identifying parallel line properties. Second, finding unknowns in parallel line equations. And third, developing equations for parallel lines. To identify parallel properties, remember this. If two lines are parallel, the gradient are equal. That means M1 equals to M2. If the gradient are not equal, then the lines are not parallel. When finding an unknown, we use the same properties, M1 equal to M2. And to develop the equation of parallel line, we'll apply the equation of straight line from subtopic 1.2, y minus y1 equal to m x minus x1. We use the gradient of the second line, which is equal to the first line, then substitute a point on the second line. When two lines are parallel, let's say L1 and L2, their gradients are equal, means M1 equal to M2. That's the key point of parallel lines. Let's check if these two lines are parallel. First line, y equals to negative 4x plus 5. Second line, y equals to negative 4x plus 9. Both of the gradients are negative 4, so M1 equals to M2 equals to negative 4. Since the gradient are the same, these two lines are parallel. Example 1b, finding the unknown in parallel lines. Now, let's solve for an unknown value using the properties of parallel lines. We are given first line, py plus x equals to 1. And second line, 2x plus y equals to 3. Rewriting both equations in gradient form, the first line is y equals to negative 1 over px plus 1 over p. And the second lines give us y equals to negative 2x plus 3. So, m1 is negative 1 over p and M2 is negative 2. By using the properties of parallel line, M1 equals to M2. This gives negative 1 over P equals to negative 2. And we solve the value of P equals to 1 over 2. Example 2, forming equation of parallel lines. Let's form an equation of a parallel line to y equals to 2x plus 1 and passing through the point negative 3, 2. We already know m equals to 2, x1 equals to negative 3, and y1 equals to 2. Substitute the value into the formula, and this will give us y minus 2 equals to 2 times x plus 3. Solving the equation, give the parallel lines y equals to 2x plus 8. Let's move on to perpendicular lines. By the end of this lesson, you should be able to 1. Determine if the two lines are perpendicular. 2. Calculate the gradient of a perpendicular line. 3. Find the unknown value in the equation. 4. Form the equation of perpendicular lines. And 5. Answer at least 8 out of 10 questions correctly in 30 minutes. This subtopic is also divided into 3 parts. First, identifying perpendicular line properties. Second, finding unknown values. And third, forming the equation. For perpendicular lines, we use this property, which is m1 times m2 equals to -1. If the product of the gradient is -1, the lines are perpendicular. To find the unknown or write the equation, we use the formula y minus y1 equals to mx minus x1, where m2 is equals to -1 over m1. Now, let's look at the examples. Properties of perpendicular lines. Let's say line L1 and L2 are perpendicular. If M1 times M2 equals to -1, then the lines are perpendicular. That's your key property. Example 1a. Are these lines perpendicular? Given L1, y equals to -2x plus 3, and L2, 2y equals to x minus 8. First, we make the second line in gradient form, y equals to 1 over 2x minus 4. So, m1 is equals to -2 and m2 is equals to 1 over 2. Then, we multiply m1 and m2, and this gives us -1. Since the product is -1, this proves that the lines are perpendicular. Example 1b. Given y plus 4x equals to 5 and y equals to -4x plus 9. Step 1. Convert the first line into gradient form, and this gives us y equals to -4x plus 5. So, m1 equals to -4 and m2 equals to -4. Multiply m1 and m2 gives us 16, and the value is not equals to -1. Therefore, the lines are not perpendicular. Finding the perpendicular line equation. To find the perpendicular line equation, we have to follow 4 steps. First, find m1. Second, calculate m2 using the formula -1 over m1. Third, identify the points gives us x1 and y1. Fourth, substitute all the value into the formula y minus y1 equals to mx minus x1. Now let's go to example. Example 2a. Equation of perpendicular line. Find the equation of a line that passes through 2, -3 and is perpendicular to the line 5y equals to 3x plus 11. First, we rewrite the equation in gradient form. Y equals to 3 over 5x plus 11 over 5. This gives us m1 equals to 3 over 5 and m2 equals to -5 over 3. Using point slope, y plus 3 is equals to -5 over 3 times x minus 2, and solving the equation, gives us the perpendicular line y equals to negative 5 over 3x plus 1 over 3. Example 2b, another perpendicular line example. Find the equation of a line perpendicular to 2y plus 4x equals to 6 and passing through the point negative 5, 2. First, we rewrite the equation y equals to negative 2x plus 3, m1 equals to negative 2, and m2 equals to 1 over 2. Substitute y minus 2 equals to 1 over 2 times x plus 5 and solve the equation, give us y equals to 1 over 2x plus 9 over 2. And that is your final answer. After you have finished watching all the example and taking notes, it's time to do the lesson activity and complete the formative assessment. If you feel unsure about any part, no worries. Just rewatch the example until you are confident. All the best and keep practicing.